Hello, students. Good morning. Hello, girls. Everyone who's out there. Okay. I hope you're able to hear me well. Please give me feedback on the comment chat, our chat box here, if you're able to hear me. Good morning to everyone. Okay, today we're going to continue with our lesson on chapter 6, which is transmission and distribution of energy or electricity. Okay, we're going to see the wiring system in our house. Okay, let me see what's on the chat. Yes, I got a lot of comments. Thank you. Good morning, girls. Good morning, everyone. Crystal, Stella, Cosin, Taishan, Xiang Hui, Hui En, Lindsay. Okay, everyone is here. Okay, that's very good. All right, okay. Okay, Stella, thanks for your feedback. Right, everyone can hear. All right, okay, so today I'm going to continue with what we did 2 days ago. Okay, I'm going to share screen. Okay, we have done this transmission and distribution of electricity. We have seen how electricity comes from the power station, excuse me, to residential areas. And along the way, you see, before it's transmitted, you need to have a step-up transformer station to increase the voltage before you transmit it to all over the country. Okay, and the system is called National Grid Network. Okay, you will see here, National Grid Network. The reason why we need to increase the voltage before we transmit is so that we can minimize energy loss in the form of heat during transmission. So what it means is actually when you start off with a lot of voltage, okay, the electricity has a high voltage. That means when you transmit along the cable, actually some of this electrical energy will be converted into heat. So if you start with a lot, all right, you end up at the end of the day when a lot of some of the heat is already released. You find at the end of the day you still have quite a lot of energy left in your electricity. But if you start with something that is low, if you start with a voltage is already low, then as you transmit along the cable, you find that more and more of the heat will be released and will be dissipated, will be lost. And then when it arrives at your city, right, you'll find that it will even be less. Okay, so that's why we want to increase the voltage first before we transmit it. Okay, now, so it comes to our city, let's say, right? So at the bottom row here is our city. And when we need to use it, we need to convert back the voltage to a lower voltage because we don't need such high voltage. Okay, 275 kilovolts is 275,000 volts, which is very high. So we need step-down transformers. So as it comes to a city here, all of these are step-down transformers. Okay, you will see here, there are step-down transformers all along the way to decrease the voltage back to whatever we need. So here at large or heavy factories or industrial areas, we need 33,000 volts. For light industries, 11,000 volts. And then for offices and hospitals and big buildings, shopping malls and so on, you have 415 volts. And lastly, at residential areas, we don't need that much of a high voltage electricity. We use 240. Okay, so this is what we learned last lesson. So now today we're going to look at your house, right? How is the wiring? How does this electricity from TNB come into our houses and how is it distributed in our house? Okay, where about the sockets and all that? What is the system? What components do we have? What is the safety component that we have so that our house doesn't burn up? Okay, our house does not catch fire when we have lightning strike our house. So we're going to look at some safety components here. So today we're going to look at the wiring system in Malaysia. Okay, before we look at the houses, let's look at the wiring system. All right, okay, let me see what else is on the comments. All right, I see some names. All right, Kai Chi, good morning. Puini, Yin Xuan, Eileen, everyone, good morning. Okay, now let's look at the wiring system. Now there are two different types of wiring system. Okay, two different types. One is called the one-phase wiring or single-phase wiring. The other is known as a three-phase wiring. Okay, now what does it mean by one phase? One phase means single, right? And three-phase, that means there are three phases. Phases means the peringkat. Okay, now if you look at the single phase, this is a single phase. As you know, we're talking about alternating current. Okay, our current that comes to our houses here, our Tenaga Nasional Berhad, it produces electricity in the form of alternating current. Okay, as we learned earlier, alternating current, you have positive, negative, positive, negative. It reverses terminal every every time. In 1 second, the change in the polarity is about 50. So you have 50 hertz. Okay, so now when it changes direction, that means sorry, it goes up positive and it goes down negative, positive, negative, positive, negative. Okay, so it changes. So this is the pattern that you get if it is a single phase wiring system. Okay, single phase. You only have one wire, one live wire. So let's look at the wiring first inside. Let me show you some wiring. Now, here you're commonly in the lab, right? You've done experiments before. You usually see two types of color. One is black, one is white. Actually, inside the wire, they are made of the same material, which is copper wire. You can see the brownish color here. Brown here shows actually it's copper. Okay, color of copper is brown. So you have these very fine wires, a few of them, all right? They are inside insulation. So this is rubber insulation. This is to prevent yourself from touching the wire so you do not get electrical shock if it's connected to a power supply. So you have rubber here, it's called insulation. Okay, insulation. And the wire, the conductor is inside the insulation. So you see that some wires have two wires inside. And this is the wire, all right? They have two. Some will have three. Okay, so you will see that inside here, actually there are, usually I will talk about our wiring system, we have three, okay? Because if you take out your socket, all right, let's look at the socket, the type of wires. I think you learned this in RBT, recommended technology. Our wiring here, we have three types of wires, actually. So you have a live wire. Okay, a live wire is very important because it brings in the current. It brings in the current to your electrical device or to your house or whatever. Okay, so this is called the live wire. It's usually coded, color coded. It's a fixed color. You can't change the color. So if you look at the brown wire, it is considered the live wire, brown color. And the other one is a neutral wire. This is called blue, color blue, okay? So you have a live wire, you have a neutral wire. Now, these two are most important because these are the ones that connects the electricity from your power supply, from the TNB. The earth wire, I will discuss it at another time, okay? So let's look at live wire and neutral wire. Why do we need two wires? A minimum of two. The additional one, earth wire, is extra, okay? You don't really need it to make your electrical supply device work. What you really need is only live and neutral. Okay, why you need two? Okay, now, so you see here, in a single phase wiring, you may have a live, there's only one. There's only one live here. There's also one neutral, and you may have the earth wire. So it's either, if you don't have the earth wire, you will see like this. If you have the earth wire, you will see additional one. Okay, so it's either two or three, right? The type of wire. Sometimes you have four. That's a different story. Now, let's look at this one first. In any experiment, let's say you go back to experiment, why do we need two wires? Okay, you see, if I give you a bulb, this is a bulb. All right, this is a bulb. When you want to connect to the power supply, usually you will connect one wire to here. Am I right? Okay, you connect it over to here, and then is that it? Will your bulb light up if I just put one wire? Okay, can you put in the chat box here? Is this bulb going to light up if I connect it this way? Okay, because I've got electricity coming. This is positive. Positive, the current flows from positive to negative. Okay, so can you put in the chat here? If I connect my battery to my bulb like this with one wire, will it light up now? Okay, I've got answer here. Corsin says no. Stella says no. Sydney says no. Okay, you're right. No. Now, why no? Why it doesn't light up? What is missing there? Why it doesn't light up? Okay, Hui-en, correct? It's no. It doesn't light up. You see something missing, right? Right? Something is not complete, right? Okay, why? Okay, try to answer that. why you cannot, the bulb does not light up if you just put one wire here. Because, okay, I give you a hint. What kind of circuit is this? What kind of circuit is this? If you only have the charges, or what we call the current, flowing from positive to this one, okay, electron doesn't flow. Actually, electron, yes, it's not complete. It doesn't flow is because your circuit is incomplete. You have to complete the circuit. There has to be a complete circuit. So whenever you need to connect any, do an experiment regarding electricity and so on, your circuit must come from the source. It goes to the load. This is called the load. The load is the item or the device that uses the electricity. Go to the load, and then it must connect back to the negative terminal of the battery. Okay, if we talk about electron flow actually flows from negative lah. All right, electron flows from negative, but the current will flow from positive to negative. Okay, so remember I told you last week, 2 weeks, I think 2 weeks ago. So if current flow, we call it electricity flow, it flows from positive to negative. But if you talk about electron flow, electron is from negative to positive. Okay, it doesn't matter about that already because it's just a convention that all the scientists in the world follow. Okay, now same concept with this. Yeah, circuit is not complete, that's right. Now let's look at this one. Imagine your power supply is your TNB. This is the power station. Okay, the battery is a power station. Okay, the battery is a power station. And this is your house. Your house is like the bulb. Your house wants to use the electricity. Okay, so your Tenaga Nasional, right? You have wires coming into the house, right? Coming into the house. Okay, you can see from the tiang electric in front of your house. There's a wire coming into your house, right? Now, will that work or not? You have electricity coming into your house. Is your house, the appliances there going to light up or going to work? Okay, the same concept. If you have only one wire, okay, this wire that brings in electricity is called a live wire. This is a live wire that brings in the current into our house. Okay, the same concept with this one, If you don't have another wire that connects back, you don't have another wire that connects back to here, you're not going to have the electricity, your electrical appliances are not going to work. So you need to complete the circuit. Therefore, you need to have another wire which goes back to the Tenaga Nasional. Okay, that's why you need two wires. And this wire is called the neutral wire. That's why you need two. Okay, so in any socket here that the socket that is inside here, when you want to plug in your this one, this is the switch here. You have 3 lubang here, isn't it? You have 3 holes here, and you plug your socket. So one of it, okay, is into the wall. You cannot see. So one of it is the live wire, and the other one is the neutral wire, which connects it back to the Tenaga Nasional. So you need to have live and neutral. Okay, so this is the minimum that you need before you can use your electrical device. You need to have it connected to the live wire. You also need to be connected to the neutral wire. Okay, you need to have both. So here, that's why you need, here if you look back at this diagram, any socket will have minimum of a live wire here and a neutral wire. Okay, now the earth wire is a protection. It is of a safety device. This is to prevent any excessive current from flowing to your body. Let's say you're touching the tape when you're ironing your clothes, right? Suddenly lightning strikes. Okay, lightning, there's a thunderstorm. So when lightning strikes, it has excessive, you know how many thousands and millions of watts, okay, up to 1 million of volts of energy of electricity. It will go into the wires, and it go into the wiring system. And then it so happen if you're touching your iron and you're ironing during a thunderstorm, if you don't have your earth wire here, the excessive, the current, it will flow into the wire, and you're touching it, you may leak, right? And then you will get electrocuted. Okay, in order to prevent that, you have an earth wire. Earth wire will send the current into the ground. So it doesn't go into your iron. So this is a safety precaution. Okay, I'll talk more about it when we talk about safety precaution. That's in a different topic. Okay, so now you can see here in any wire, you need to have minimum 2. You see one red one, actually it's brown. You follow the coding system. Brown is for live and blue is for neutral. Okay, so I assume this is supposed to be brown, right? This is supposed to be brown. Okay, so you need 2. That's why you see in your single phase, you only have one live wire. You only have one brown wire. This is your live wire. So if you're talking about single phase, go back to this one, single phase, you can see there's only one live wire. And that is the only wire that gives you the current. It brings in the current from outside. So there's only one. So it goes up and down because it's alternating current. Okay, there's only one live wire. Now, that is one single phase. Now, single phase wiring is usually suitable for normal electrical usage. That means the normal kind of usage we have in our houses. We don't use a very high ampere, a lot of electricity. We don't have very need for high ampere, okay, or high voltage. So it's usually for houses, all right, or the usage of electricity does not exceed 10,000 watts. What is how powerful your oven, your washing machine, all combined together. You don't need as high as that, okay? Or maximum up to 50 ampere. So our housing, all these houses are electrical appliances, usually about up to 30 ampere only. We don't have up to 50 ampere, okay? So this is suitable for normal usage for houses and so on, and also residential areas, kampong and all that, okay? Normal houses. So I'm not talking about big house or big building. Now that one needs more. So you need to have a different kind of wiring. For buildings like shopping center, shopping mall, for hospitals, for a big building with many offices inside there, okay? Or let's say a big factory, okay? That one needs a different type of wiring. It needs a 3-phase wiring. Okay, let's compare and see. The single phase, just now you only have one live wire, so it brings in this current, and the current has only one pattern because it's only one live wire. Now, if you have 3-phase wiring, actually you have 3 live wires. Okay, the live wire, there are 3. So you can see here, if we talk about the wiring system, here you can see here 4, isn't it? From here, 3 of them will be the live wire. There are 3 live wires. And the other one will be the neutral. So the neutral is the blue one. This is the neutral. Okay, and you can see the green and the blue, black and the yellow, that one could be live wires. So if you were to see here, now here is your wire with 5 wires inside there. One could be the earth, then one is neutral, and your live wire, there are 3. Okay, now why 3? Because you have 3 live wires, you have 3 patterns. There are 3 waves patterns. So here, look at the green and the blue and the red. So each one of these patterns is formed by one wire. So you see, let's look at the red one first. Okay, our green one. Okay, green one is, let's say, wire number 1. So it has this pattern here where it is maximum, right? The others are not maximum yet. So maximum, after that, it goes down, minimum, then it goes up, maximum, and it goes down. Okay, you can see the wave for the first one here. Now you see, when there's a peak here, when this is maximum, you find the others are not maximum. Okay, it doesn't matter because you already have one that's maximum. Now, when your green wire, the green one, is at minimum. Minimum means lower voltage, right? It doesn't matter. You have others to increase. You can see your P, your red one. The red one is up already. You see, your red is up, and then your blue is also up. So it doesn't matter. It's like when one is down, the other 2 can compensate. It's like hopu like that. Okay. So in other words, this you have 3 persons doing the job. Okay, like 3 persons. So the job is more efficient, isn't it? You have one that's down, but the other 2 are up. So it's like a backup. So here, in this 3-phase wiring, you can find that the current that is produced is more consistent. It's more stable. The current that is produced is more consistent and more stable. Because when one is down, the other 2 wires are more or less, it's already peaking. So it has got ups and downs, but it's not at the same time. Okay, one is up, the other is down. But when this one is down, the other one is up. Okay, so you can see that the electricity that is produced or that is conveyed or that's transmitted is more consistent, more stable. And this is important for machinery that requires high voltage or requires a lot of electricity. Okay, so for commercials like businesses, right? In let's say shopping mall, you have a lot of aircon. Okay, every shop literally have its own aircon, and the shopping mall has so many shops inside there, isn't it? And industrial area and hospital, you have so many wards, so many buildings. There are so many different departments that need a lot of aircon. Every department has an aircon and so on. Every room has an aircon. Okay, so you need the usage of electricity is very high. Okay, so you need the electrical appliances have high power, so you need at least more than 10,000 watts, right? All added together. You also have current that's very high. So three-phase wiring is more suitable for that. Okay, more stable. The current is more consistent. So let's look at some differences between the two-phase, single phase, and the three-phase. So you can see what is the advantage of having a three-phase. So three-phase power supply delivers power at a steady, constant rate. Okay, but you can see from the pattern that one is up, the other if it's down, then the other you have up also. So it's not always down at the same time. So this is up, this is down. So you can see it compensates. So it's more consistent. So you can find that three-phase power supplies are more efficient. Okay, it can transmit 3 times as much power as a single-phase power supply. Okay, and then look at the differences. This is single, right? This is single, and this is three-phase. If you want to compare, let me give you some facts, so you have some information to go along. If the question asks for it, you are able to answer. Okay, so single for power delivery is not consistent because of the peaks. Peaks means the mountain, it goes up. All right, after that, it will dip. Dip means come down. So it up and down, it's not consistent. You can't help it because it's alternating current. It's not direct current. Direct current is all consistent. Okay, you can see the graph there, same straight line. But alternating is up and down. So it's not consistent. You only have one. But you have three-phase, right? You have 3 conductors, you have 3 wires, right? And each one have different wave at a different time, different pattern. So you'll find that the power delivery is always steady and always consistent. The peaks and the dips are compensated. When this one peaks, the other one will dip. When this one dip, the other one will peak. You see? So it like more or less it balance out. Okay. So now for single phase power supply, usually the voltage is about 230. In Malaysia, it'll be 240 . Okay. In UK, it's 230. So 240. And three-phase power supply, the supply voltage is 450. So this is suitable for, like I said, businesses, buildings, hospitals, and also schools as well. We have three-phase wiring. And also you have hospitals and shopping mall, right? And basically these places which have a need for a lot of this. Even for houses, if you have bungalows, mansion, very big buildings where you have 20 rooms, okay, 30 rooms with lots of aircon, you also need three-phase power supply. You need three-phase power supply. Okay, depends. Not every house. I think those houses which are very big, a lot of aircon, a lot of rooms, definitely you need three-phase power supply, not single. It's not enough. Okay, so for normal houses like us, okay, not so rich. I'm not talking about you, I'm talking about me. Okay, so it is normal, right? You just have the 240, a single phase. So single phase supply is relatively less efficient. Okay, not so efficient for the same power delivery. For three-phase, it's more efficient. It can deliver 3 times the power compared to the single-phase power supply. Just additional wire, it gives you 3 times the power. Okay, and that is for usually residential and domestic needs. Domestic means houses, all right. Residential is also houses, okay. And for usually for three-phase, it's for commercial center. Okay, we call it businesses, right? Shopping center, businesses, big buildings, and so on. Now it is single phase, right? Ideal for small loads like electrical appliances for lighting, for lights, for heating, all right, microwave oven, this. For three-phase, right, is more for industrial motors. Industrial motor, that's why in the factories and all that, they use a lot of electricity, very high. You know, you need a high power machinery. So they need a lot of this voltage, high voltage, and also higher currents. Okay, so this is single and three-phase. So I've covered single and three-phase. Now I'm going to go through how is this connection in our house. Okay, the wiring system. So you know that the Tenaga Nasional supplies the current or the electricity to our houses. All right, now if you were to go to your porch, you know, porch is where the place your father parks a car or your mom parks a car there. You will see that at the side, at the wall there, you have a like a circuit board. It's a board, it's not a circuit board, it's just a board. And you have a meter, isn't it? You have a meter there. This meter is important. You can see every month, every month this TNB will send a person to come and read your meter, correct? He comes and read your meter. Sometimes you use the teropong, right? You can see from far away. Use that binocular thing, and then he will punch it into his machine here, the number that he sees there, and it will print out your electricity bill for the month. Okay, it prints out and it put into your mailbox. Okay, now this is called an electric meter. This is one of the things that you can find outside your house. This is a meter that measures how much electricity you have used for that month, okay, or for the certain duration of time. So that's why when it comes open, you will see last month was not what number, and this month is what number. It tolak minus this month and tolak minus last month. You will see the difference. So you have used this much of electricity units in this time, and you have to pay accordingly. You can pay how much, okay? And then besides this electric motor, you also have the main fuse box. So these are the two things that you see outside. If you don't believe me, after this lesson, you go outside, have a look at your porch and look at the wall there. You will have these two things. Okay, so I'll label this main fuse box and electric meter. What is the fuse box for? Now, fuse box, whenever you see the word fuse, it is actually a protection. It is a device to protect your house, protect the electrical current, protect the circuit. How does it work? Excuse me. When you have a fuse, it has a special wire inside there. The special wire inside there has a low melting point. It is easy to melt. Okay, there's a special wire, not a normal wire. Normal wire normally doesn't melt very easily. But low melting point, this fuse is a special wire, it's a low melting point when the current becomes too high. Now, when does the current become too high? How come suddenly the current can become too high? It usually happens when your lightning strikes your house, when you have a thunderstorm. Okay, let's say you have a thunderstorm. And so happen the thunderstorm produces lightning, and your lightning strikes your house, lightning strikes the wires up there. So you have your all this antenna, all the wires there, it strikes, and then your current inside here will become very high. Because as you know, for lightning, the voltage can go up to 1 million, okay, which is extremely high. So that causes a lot of current. The current will increase, and then it's going to be very hot. Okay, so it's going to be very hot because the current will convert it into into heat energy. So when it's very hot, what happens is, if it's very hot, this fuse will have a low melting point. So it's going to melt. It will it will break. We call it tuan. Tuan means it will break. Yes, it will just melt. When it melts, so you will get an incomplete circuit. So this one, let's say this is here, it already melts. So when it melted, your current doesn't go in anymore, and your house is safe. You do not have the heat enter your wire, and it's not going to burn your electrical appliances. It's not going to burn your TV. It's not going to burn your computer. It's not going to damage any of your appliances inside your house. Okay, so this is a safety. It is good that it can melt, so that when the current is too high, okay, high current, the current suddenly will increase, right, when they're struck by lightning. So when the current becomes too high, it becomes going to be very hot. When it's very hot, right, it may even burn your electrical appliances. So when you have a fuse here, it is a protection. In case your house is being struck by lightning during thunderstorm, immediately the what you call the current does not enter your house, and you are safe. Your house is safe. Okay, it doesn't get this electrical surge. We call it surge. Surge means excessive current. Suddenly the current goes up. It's called surge. Okay, so here you have the main fuse box. It serves as a protection to prevent excessive current from entering your house. Okay, I repeat, to prevent excessive current from entering your house. An electric meter is to measure how much you've used for that month. Okay, so this is the wire, right? This is, you look at your outside, there is going to be a cable that comes up from the tiang lampu, not tiang lampu, the wiring outside your house there, go directly into your house. So usually black color. If I'm mistaken, it's usually black color, right? Inside there will have a live wire. Live wire will bring in the current. This is a live wire. And there's another one, neutral wire. It connects back to TNB. So you must have a live wire. See the direction? Live wire brings in the current. Neutral wire brings the current back out. Okay, so live wire is 240 volts, neutral wire at 0 volts. Okay, so you can see the difference there. So the current will move in. Okay, so this is outside your house. Okay, so I draw a line here. This is outside. You can see outside house. Now, once it comes in from the meter, you go into the living room, right? You look at your living room. This wire enters your house from the electric meter. It is going to be connected to a board. You look at the living room, there's going to be at the wall there, somewhere near your switches and all that, there's going to be a big, what you call a board. Okay, it's going to be a board here. Now, this is called a fuse. There are two things here. There's a consumer unit and a fuse board. This is a box here. In fact, I'm talking about this whole thing. This whole board here. Okay, there's one board here. Now, inside here, you have certain things, certain components. Okay, so number one, you have a main switch. Now, what is a main switch? Now, as you can see here, it's a switch. Switch is to switch on or switch off the current. Let's say you need to repair something in your house, or you send for the electrician, okay, the repairman. He wants to install something in your house, or he wants to fix something. The first thing he will do is he needs to switch off the main switch, right? So that he can do the repair safely. He will not get electrocuted. Okay, if this main switch is on, that means the current will still enter the house. If he did something wrong, he touched the wire, it's called a live wire, he will be electrocuted. He will die. Okay, so you need to switch off. Once you switch off the main switch, no current enters the house. Everything you cannot use for the time being. Just for a short moment, you repair the things first. Okay, so that's the main switch. You can switch it off. If you switch it off, nothing comes into your house. There's no current. Okay. Now, secondly, you have an ELCB. ELCB stands for Earth Leakage Circuit Breaker, ELCB. This is also a protection, call it a precautionary device to help to protect your house. Okay, how does it work? It works just like a fuse, but this fuse you can reset. Just now I mentioned this fuse up here. This is not reset one. Means the wire, when it breaks, it's already broken. You need to get a repairman to buy a fuse wire and put back the wire. Or if you can do it, you go to a DIY shop and you buy a fuse wire. Buy fuse wire, don't buy normal wire. You cannot replace a normal wire, it's dangerous. You must buy the special fuse wire which has low melting point. Then you can connect it back, right, and put it back there. If let's say that it burns, right, accidentally. So now for inside here, this one you don't need to buy the wire and change it. This one you can reset. Now I'm sure you have seen. Let me give you an example. During a thunderstorm, sometimes have you experienced when suddenly there is a lightning strike? It's very loud, like that, right? The sound, boom, like that, and then suddenly your whole house goes dark, right? Like all suddenly 停电. Suddenly like it's a power outage like that. Okay, and then what happens? Your father will take the torchlight, all right, and go to that board here, and what he does, he will push back a reset button. Okay, that is the ELCB. So it suddenly, why it go off is because the lightning strike, all right, and then for that time, for that split second, the current is too high flowing into your wire, so it automatically, this system breaks itself. So the wire tuan, okay, it just break for the time being, so that the current does not enter into your house and burn your things in the house. Okay, so it just stop. That's an on-off button. there is a button here. You go to the living room afterwards and go and see, there's an on off button here. All right, so this, let me show you. Sorry, I have this. I've forgotten. I've got this. Where's my picture? ELCB. Here. This is the here. This is the box I'm talking about. Okay, you look at your wall there. This is the box and this is the ELCB. There is a reset button. There's a reset button here. So there's an on and there's an off here. So maybe on is up or off is down. I can't remember lah. This could be the other way. One is up. This is on, or this is off. So when the lightning strikes, the button will just, it will go off. So what you need to do is you just need to push it up and your house will be okay. Your lights will come on, your fan will come on, unless it's rosak lah, right? If it's already been damaged by the lightning, then of course that thing will not work. But the others will work. Okay, and that is the ELCB. All right, this is the ELCB. So you see this is a fuse box, right? That whole thing. After I show you the fuse box, this is the ELCB, and there's another picture here that shows the ELCB. So you can see here, there is the switch here. This is an on. With the switch is pushed up, maybe it's on. There's a button here, and you can see off here. You can reset this. Okay, this is the ELCB. Now, there is another type, it's called MCB, miniature circuit board. It also serves as the same thing, but it's smaller. And it controls one part of your house. So this MCB will have many. There are many of this, but there's only one of this ELCB. Okay, so you can see here. Now here, all these small little ones, all these are MCB. See all this MCB, all this MCB. Why do you need so many? Because one of it connects to, it controls the electricity. Let me go to the kitchen. This one is for your kitchen. This one is for your living room. Okay. This one is for your upstairs. Maybe upstairs you have your bedroom there. Okay. One part of your house is controlled by one MCB. All right. So you have many. If your house is very big, of course, you need a lot of these MCBs. Each one is actually a fuse. A fuse that is resettable. You can reset it. Okay, so this is the box here. This is the whole box here. You can see here, right? After you go and have a look, look at your house one. So this is the ELCB. Now I just also mentioned your MCB is going to different electric appliances. Okay, so each one connected to one part. So ELCB is only one, but your MCB you have different, many. It's all put into a box there. This is called consumer unit. This whole thing is called a consumer unit. Okay, this one also. And you have fuse box because here all these MCB are actually fuses. All right, okay. So this is what happens. Now, if let's say there is current, excessive current, very high current enter your house because of lightning strike. So there's another safety device called an earth wire. So if your current is too high and it finds your way into your wire, this excessive current will be flowed to the ground. So you have a earthing wire or earth wire. Okay. In the socket also, each of the sockets, you see all this socket? That socket where you switch on the switch on, I got three. This one. Talking about this one. Okay, your three lubang one. The socket you plug in your charger there. That socket. It will also have your earthing wire. The green one, if the current happens to find its way into the wire, it will all flow to the ground and you are safe. Okay, you do not get shocked by touching the thing. When you're ironing it, right, your electricity does not go into the iron, it will go into the wire, it goes right to the ground. So the excessive current is called grounded. Grounded means you put the current to the ground and it doesn't go into your body, you do not get electrical shock. So this is a protection. This is a protective device. Okay, so power circuit made up of, you need to have three. Some have two. Depends on the socket. But you will have a live wire if you have a 3-pin plug. If you see a 3-pin plug, this is a 3-pin socket. 3-pin socket. Definitely one is for wire. The other one for live. The other one for neutral. Okay, and here the lightning circuit here. Right, this is your lights here. So this is your switch. You want to switch on or switch off your lighting. Right, this one uses your live wire, and this one neutral is to return back. Okay, so you can see here that you need to have at least your live and your neutral. The earth wire is an additional one for protection purposes. Okay, so this is how it works. So let's look at here. This is, okay, just to go through here. Now this is from your diagram, okay, to show this is a national grid network. All right, your power plant TNB is here, supplies to the pylons here. This is your pylon, right? And this is the cable. When you have the substation, you have to try, we call it step down the voltage first. Then it comes to your house at 240 volts. So when it comes to your house, first thing it enters is your meter. And of course, there is a fuse here also. This is outside. Okay. Then after that, it goes into your house. Now this one, they put an additional one. If you have solar panel, you have an additional thing to actually is inverter to convert your AC to DC and so on, and it works into your house. Okay, so this is another diagram. You see the wiring system in the house is complicated, right? So you have TNB here. Your power supply comes in through the live wire. It goes into electric meter. Then it goes inside here, and then it goes to all the rooms. So before they build the house, they must put the wire in the wall. Okay, you see that? It's quite not just build the wall, no. You have to hide the wire inside. That's why you can see it's not an easy thing to think of all these things. Okay, how many sockets you need for the room? Normally they will give you at least 2 or 3 lah. Okay, depends on your needs. Okay, so this is all the wires is hidden inside the wall. Okay, when they build the house. Okay, so next one, a little bit more before I stop the lesson. Now, you have seen your plugs, okay, the socket that you put your plug that put into your socket. You have seen some of the 2 pins and some are 3 pins. Okay, 3-pin plug and 2-pin plug. What's the difference? So you can see different countries will have different sizes and different what they call shapes. So in Hong Kong, Hong Kong was a British colony, so like Malaysia and so on. So we use the same type, like Britain. This one is squarish one. Okay, the 3 pins there is square one. Okay, this type. So this one like that. Okay, in Hong Kong and Malaysia as well. Now, if you go to India, you'll find the socket size or the shape is different. That plug in the plug is round. So, right? So difficult. You cannot plug in. Your square one into the round. It doesn't work. You need to have an adapter. In North America, okay, you have a round one and two like 2 slits like that. Thin one. The live wire and the one that is not square. It is like 2 slits like that. Okay, so you need a different type. See, every country have their own system. Japan is like this, right? Just 2 like that. Or maybe you have a additional one. And Europe is round. Okay, so you can see different types. So when you go traveling, I'm sure you've gone overseas before, right? With your parents and so on. Usually when you need to go overseas, you need to charge your phone, you need to charge your devices, you have to bring an adapter. We call it a universal adapter because different countries will have different the configuration, okay, the shape of the pins. So your square one cannot enter your round. Your round one cannot enter the square one. So you need to have a universal adapter. Okay, it's not expensive. You just buy about less than 20 ringgit, you can get 1 unit. Okay, you plug it into the socket of the wall first, and then you plug in your charger into it, and you can use it. All right, so what's the difference here with 2-pin plug and 3-pin plug? Basically, it's very easy to see. When you have a 3-pin plug, 3 pins here. What are the 3 pins here? You need to have live wire, of course, definitely your live wire, 1 neutral wire, and the additional one is earth wire. I just meant the earth is additional. In order to work the electric device, you just need your live and neutral. The earth is for protection. Okay, in case we call it a surge in the current, then it might enter you are touching the electrical device, you're going to get electrocuted, you're going to get shocked. Okay, so this is a 3-pin plug, right? It's usually safer to have a 3-pin plug because you have the earth wire. So usually it's for devices that require heating, like your kettle, your microwave and all that requires higher amounts of current. Okay, but for your TV, you notice TV, you just sometimes you only 2 only. Radio, you have 2 only. Okay, so that one does not require so much of a current, right? So it doesn't have the heating kind of capacity, so you do not need maybe, do not need the extensional earth wire lah, right? So here, hair dryers, electric toothbrush, the smaller items right, you can use your 2-pin plug. So you see only 2. So when it's only 2, you only have your live and the neutral. Don't have the earth, okay? That is the difference there. So here, when you talk about safety, right, definitely it is the 3-pin plug which is safer because of this earth wire. And remember the color, live is always brown, neutral is always blue, and earth wire is yellow and green stripes. Okay, last time they used to put green, I think, and then neutral wire last time they put as black, and then the live wire put as red. So now they change it. This is the new system. So follow the colors here. All right, okay. So this is what happens when you have your earth wire. So this is additional one. If this is iron, right? The iron that you are holding, let's say your hand is holding here. You're ironing the thing. If let's say there's a short circuit, when there's a short circuit, the current will increase. So when the current increases, it becomes hot. So remember the sequence. If there is a short circuit, later on we have a short circuit, the topic. So your current increase. When current increase is not good, because sometimes you just need the minimum current to work your electrical appliances. If your current increase to be too high, because maybe lightning strike, that's one reason. Another reason is a short circuit. So your current will increase. This is going to cause heat. All right, this is going to cause heat. And then when there's heat, if you have a fuse, then no problem. Your fuse will melt. Fuse will melt. This will help to stop the current from flowing in. But let's say there's no fuse there, right? Your fuse failed already. So your heat increases, your current increases, you are touching the thing, your current will move into your hand and you're going to get electrocuted. Okay, in order to prevent that, there is this is the earth wire. The earth wire will bring the current back to the ground. So this is a symbol for grounding. Grounding means the wire goes, the current goes to the ground. This is called earthing or grounding. Okay, it doesn't enter your iron at all. All right, okay. So this is what I want to tell you the type of wiring system and also the 2-pin plug and 3-pin plug. All right, in the next lesson we talk about these safety devices again, the fuses, types of fuses, and how to calculate the current, okay, that is needed to use the correct fuse. All right, okay. So we will stop here now. Then we will proceed to Google Meet to do questions and for discussion. All right, okay. So I hope everything okay, no questions here. All right, okay. So for those out there, all right, I will see you in my next lesson. Okay, so the girls, please enter my Google Meet. All right, okay, bye-bye. See you.